Hi, welcome to Concept Based. I'm John Hepworth. This one's for Year 11 Advanced students. We are in the functions section of your syllabus and we're looking at reciprocal functions. This builds upon your Year 10 path section nonlinear functions hyperbolas. So the hyperbolas were relations you were thinking about previously. Now we're calling them reciprocal functions. In your syllabus, when you are first introduced to these, they are just in the form of k over x. But I have put in the +1 just to make it a little bit more of a revision of hyperbolas when we look at this as a reciprocal function. So the question is, graph f of x equals -3 on x plus 1, taking into consideration when x goes towards infinity and when x goes towards -infinity. So hopefully there's a couple of rules that you recall from hyperbolas that you will take into consideration when graphing these reciprocal functions, and they are as follows. One is the asymptote. So in mathematics, we can never divide by 0, ever. If you haven't seen the video of how if you divide by 0, you can make 2 equal to 1, I'd look it up. It's pretty clever the way it uses difference of two squares as a factorization, and then they do a division, and the division is by 0, and it doesn't look like anything in the algebra, but it results in the answer 2 equals 1. It's pretty clever. But so what it actually confirms is if we divide by 0, all the logic falls out of our mathematics. So in this situation, in this fraction, we can't divide by 0, so therefore x could never be 0 in this fraction. Otherwise, we're going to run into this problem. So where does x equal 0? X equals 0 on the y-axis. So we have our vertical asymptote at x equals 0, which you may recall from your hyperbolas in year 10, you always had some sort of vertical asymptote. The next bit is a little bit different. Now, in your syllabus, you don't formally do limits, but as a result of doing graphs, you sort of do limits. So we don't formally do it, but we have to understand what happens as something approaches some position on the graph. And the place that we usually look at what it approaches is either an asymptote or infinity. In this case, we've got both cases. We want to see what happens as this graph goes out towards positive infinity and negative infinity. Now let's see what happens if we just go and put positive infinity into this graph. So -3 over positive infinity plus 1. What would that possibly equal? Well, you can certainly grasp the concept that any fraction, when the denominator is really large, is a very small fraction. So like 1 over 2 is not very small. 1 over 50, that's pretty small. 1 over 1,000, that's tiny. Over infinity, it's essentially 0. But we still take into consideration the fact that this came towards this point from a negative value. So we actually approached 0 from the negative side, because -3 divided by a large number is a small negative number. So if we're approaching 1 from the negative, well, we're approaching 0 from the negative side, then we approach 1 from the negative side when we add 1 to this function. So if we're approaching 1 from the negative side, what that means on our graph is that we would come up from the bottom. Now, if we consider -3 over negative infinity, we have a different situation because a negative divided by a negative cancels, and we end up coming towards 0 from the positive side, and therefore if we add 1, we're coming towards +1 from the positive side. So if we had a line at 1, then we would be coming at it from the positive side. Now, this could have been like this. It just depends on whether the hyperbola is in certain quadrants. So we've got this line at y equals 1, and we're approaching it from either side. So let's just go and take that line at y equals 1 and put it in. So y equals 1. And we know off at infinity, we approach it from the bottom, and off at negative infinity, we approach it from the top. So we've got this part of our graph drawn so far. Now, we also know from our learning in hyperbolas that this reciprocal function is negative. -3, not on the page, -3 over positive x. So if it's a negative over a positive, it's a negative. So we're talking about a negative hyperbola or reciprocal function. So if it is negative, it doesn't go over here. This is where the positive ones go, you may recall. It goes in the other section, which makes sense because our limits sort of said that it goes in the other section. It goes in this bit and this bit, and that's where the sort of heads of our arrows are from our limits as they go off to infinity. So we know that we're going to be going up towards this asymptote. Now this one down here, we have to think, oh, hang on a second. We're about to cross the x-axis. So this is going to come down and go across the x-axis somewhere. I need to know where that is. And when functions cross the x-axis, we call them zeros. And we're going to try and find when it equals 0. So here we get -3 over x equals -1. We times x across and we get -3 equals -x. And then we divide by -1 and we get x equals 3. So we can now go and cross this at 3. We don't want to move that. We want to just go and cross this. And so we can put in a 0 at x equals 3. Now this part of the graph over here, on the left-hand side, it's sort of just floating off in space. I tell my students to at least put one point on it. So I would choose a point that's really easy to put on the graph. So when I'm looking at a function that is -3 over x plus 1, I'm going to pick a number that's as easy as possible. And I'm going to pick the number -3, because -3 divided by -3 is 1, plus 1 equals 2. So I now know at -3, now I keep my scale of my graph the same, because if I don't, a marker in the HSC could mark me down. And then I'm going to hit my graph here at 2. So I'm actually at this point -3, 2. And that stops that part of the graph just being off in space anywhere. When we graph in the HSC, we want to see some sort of accuracy, and that's of all parts of the graph. So if there is a graph that doesn't go across the y-intercept or the x-intercept, it's great to put a point on it just to at least know that you're in the ballpark, and then markers would be happy that you've graphed that relatively accurately there. So summarizing, we found a horizontal asymptote, we found a vertical asymptote, we found a zero, and we found some other point. We took into consideration whether the reciprocal function was positive or negative, and we get our graph out. Now, I want to do a little side note here. This may be the first time you've really thought about how these horizontal asymptotes appear. Really, they're not asymptotes, because an asymptote is generally something that you can't cross. Like you're not allowed to have that value in the function. But asymptotes that are horizontal can be crossed. They're really just telling us about what happens at infinity. So if you ever draw a graph and your graph crossed the horizontal asymptote and then came back to it, and you thought, oh, I can't do that, that's not allowed. That is allowed. It might actually be a graph that does do that, and you may see examples in the future where that happens. So don't think to yourself, oh, we can't cross that horizontal one. It's just telling us what's happening as it goes off towards infinity. Okay, so hopefully that was pretty straightforward. If it wasn't, as always, I'm recommending that you go back to your Year 10 nonlinear content and revise some of the hyperbola information there. That will help you for these reciprocal functions. Otherwise, if you felt like the nonlinear last year was pretty easy, then that's going to make it quite easy for you in these in this function part of your syllabus.